General Motors, the biggest automaker in the US, is diving headfirst into the electric vehicle game. They're not just talking about it, they're betting their future on it. GM's CEO, Barra, has a bold vision for an all-electric future, where cars contribute to zero crashes, zero emissions, and zero congestion. She's confident that GM will dominate the US EV market by the middle of the decade, claiming they'll take the #1 spot. The star of their EV push is the Ultium battery. This isn't just any battery, it's a game plan wrapped in cutting-edge technology. The Ultium battery starts with a single cell, a building block that can be adapted to fit into all sorts of vehicles. Imagine a system so versatile it can power a massive Hummer, a sleek Cadillac Lyriq, or pretty much anything else GM dreams up, and do it quickly. GM is putting its money where its mouth is. The company plans to invest $35 billion into electric and autonomous vehicles by 2025. They're aiming for the capacity to produce 1 million EVs annually and plan to launch over 30 electric models globally during that time. Most of these will run on the new Ultium platform. By 2035, GM intends to make all its light-duty vehicles electric. But they're not stopping at personal cars. GM is also expanding into the commercial EV sector with its BrightDrop brand. They've already started delivering BrightDrop vehicles to FedEx and secured a contract with Walmart. It's clear they're serious about carving out a big slice of the EV market. Of course, GM isn't the only player in the EV game. Automakers everywhere, big and small, are racing to roll out electric vehicles. Startups are popping up left and right, hoping to make their mark. So what makes GM's Ultium platform stand out? They believe the answer lies in their partnership with LG Energy Solutions, a battery cell manufacturing powerhouse, and the construction of 3 massive battery factories in the US, located in Ohio, Tennessee, and Michigan. General Motors is confident this collaboration and their innovative battery technology will make their vehicles among the best on the market. To see what all the fuss is about, CNBC went behind the scenes at GM's battery lab. This is where the magic happens, where engineers are perfecting the Ultium platform and ensuring all the components work seamlessly together. The Ultium platform isn't just about better batteries. It's a complete overhaul of how EVs are built, from the motors to the software. The Ultium battery itself is a large-format lithium-ion design and the heart of GM's EV strategy. Tim Grew, GM's electrification expert, explains that it's all about combining advanced components into a system that functions flawlessly. The battery's modular design means it can be scaled up or down to fit everything from heavy-duty trucks to sleek sedans. GM has already rolled out several vehicles using the Ultium platform, including the GMC Hummer EV, the Cadillac Lyriq, the Chevrolet Silverado EV, and even a fully electric Corvette. Upcoming models include the Cadillac Celestiq sedan and the Chevrolet Blazer EV. Understanding how a battery works might sound like a science class, but it's actually quite fascinating. A battery generates electricity through a chemical reaction, with an anode and a cathode on either end, separated by chemicals and an electrolyte. When the battery discharges, ions move from the anode to the cathode, generating electricity. When it charges, they move in the opposite direction. GM engineers describe it in relatable terms, comparing the anode and cathode to parking garages, where lithium ions park depending on whether the battery is charging or discharging. What makes the Ultium platform particularly innovative is its battery chemistry. Traditional EV batteries often rely on cobalt, which is expensive and difficult to source. Tesla, for example, uses a mix of nickel, cobalt, and aluminum in many of its vehicles. GM's Ultium platform is breaking new ground with a chemistry that uses less cobalt and incorporates other materials to reduce cost and dependence on scarce resources. They're even working toward cobalt-free designs, which could be a game changer for the industry. This effort isn't just about making batteries cheaper, it's about making them better for the environment. Mining cobalt and other rare materials can be both environmentally damaging and politically sensitive. By reducing reliance on these materials, GM's Ultium batteries could make EVs more sustainable while also lowering costs for consumers. Beyond the technology, GM's vision is to build an entire ecosystem around EVs. Their 3 new battery factories are just the beginning. They're also investing heavily in research and development, strategic partnerships, and new manufacturing techniques to ensure they can scale production quickly and efficiently. They're not just trying to catch up to companies like Tesla, they want to leapfrog them. One of GM's key innovations is how they pack the cells. Rather than leaving gaps between them, GM arranges the cells tightly side by side, reducing wasted space and maximizing energy capacity. This design is incredibly flexible, allowing GM to adjust the shape and configuration of the cells depending on the vehicle's needs. For example, their cars in China use a prismatic can design, which is shorter and wider compared to the longer cells typically used in the US. Speaking of China, the country is the world's largest electric vehicle market, and GM has made some serious moves there. In 2021, GM sold 2.9 million vehicles in China, with their new energy vehicles, including both plug-in hybrids and fully electric cars, seeing major growth. Their Buick Velite EV lineup, for instance, doubled its sales year over year, reflecting the increasing demand for EVs in the region. In fact, GM has been so successful in China that it now sells more EVs than Tesla in the country, which is no small feat given Tesla's prominence in the global EV market. The Ultium platform's flexibility goes beyond just battery chemistry and design. It extends to how the batteries are assembled within vehicles. GM's modular approach means that the battery modules can be arranged both vertically and horizontally, depending on the vehicle's requirements. For example, a full-size truck might have up to 24 battery modules stacked together, while a smaller vehicle like a sports car might only need a single layer of modules. This adaptability allows GM to optimize battery size and configuration for each specific model, ensuring efficiency without overcomplicating the manufacturing process. Take the Cadillac Lyriq as an example. Its battery pack is designed with 12 modules, carefully chosen to meet the performance needs of the vehicle. Meanwhile, for a smaller car like the Chevy Equinox EV, fewer modules are required, resulting in a shorter and more compact pack. This level of customization ensures that each vehicle gets the optimal battery design, depending on its size and performance requirements.